Hello everyone, glad to see you. Today we want to talk about profile of a line. As we can see here in this figure, we have line profile. We are going to control that profile. It should be in the mentioned interval for each cross section separately. It is 2D version of surface profile. As we can see here, we are going to use this symbol at top left for line profile, and each section is going to control separately, while for surface profile, we are going to control whole surface at the same time. Here we are going to have two lines, and between these two lines, we can see the profile should be in that two lines. Let's say that to profile. Let's see this example. We have line profile, TZ is 0.2, back to plane A. As we can see here, we are going to have two lines with this distance 0.2, and for each cross section, the profile should be in that boundary, in that TZ 0.2. We are going to use coordinate measuring machine to control the profile of a line for each cross section separately. Here we have just one reference per lane. We are going to use the orientation of these lines here for this surface. At the right hand side, we are going to have line profile TZ is 0.006. We have two planes A and B, and we are going to use basic dimension. It means we are going to control the orientation and location of this profile from X to Y. As we can see at the bottom, we are going to have two lines, and the TZ is 0.006, the distance between these two lines for each cross section. We are going to use basic dimension to have these two profiles, two parallel profiles with that TZ. And this wavy profile, this through profile should be in that interval. Here we have this line profile TZ is 0.05 back to plane A and reference B. As we can see, we are going to have these two curves should be parallel to A and centered on B. And this wavy surface should be in that interval. And the distance between these two boundaries is 0.05. 0.005. We are going to control the orientation based on the using basic dimension or not. We are going to control the location of that as well. Here we have another example. We have line profile TZ is 0.2 back to plane A and B. It means for each cross section we are going to have two lines parallel, and the distance between two lines is 0.2, and the profile should be in that boundary, that wavy profile, let's say, for each cross section. We have another example here. We have line profile TZ is 0.03 back to planes A and B. We are going to have this interval between these two parallel lines for each cross section. The distance is 0.03, and that wavy surface should be in that interval. And however, here we are going to control the orientation, and based on using or not using basic dimension, we are going to control the location as well. Here I would like to highlight, whenever we are going to use line profile, the TZ for line profile is smaller than the TZ for surface profile. We are going to use line profile for a specific line. When we have a contact, for that contact line, we are going to use line profile beside surface profile. While for the circularity and cylindricality, we have the same order of the TZ. And the same for straightness and flatness, we have the same order for the TZ. And for circular run out and total run out, we are going to have the same TZ, but for line profile, we are going to have a smaller value for TZ in comparison with the TZ for surface profile. We are going to refine it. We are going to decrease the tolerances for line profile. Let's see some example in this issue. Here, we have both of them. We have, let's say, line profile with a TZ of 0.2 and surface profile with a TZ of 0.8 respect to plane A and B. It means we are going to control that profile, orientation, and location. We have basic dimension here, as we can see, 8 and 10. We are going to control that one with surface profile. But for each cross section, we are going to control the wave of that lines. It should be in that table. At the bottom, you can see we have these two blue lines. The distance between these two is 0.8. It backs to the surface profile. We are going to control the orientation and location of that surface. And for each cross section, we are going to control the wavy lines for that cross section. It should be between these two, let's say, brown colors. The distance between these two is 0.2. Here we have another example. The top it is the same. We have TZ 0.4 for surface profile respect to plane A and B, as we can see here, A and B. And we are going to control the orientation and location of this surface by using this surface profile. But for this wavy at the top, we are going to use this line profile. The TZ for that is 0.2. But at the bottom, we have the same geometry, but for the line profile and surface profile, we have the same situation. We have two plane A and B, and we have TZ for line profile is 0.2 and TZ for surface profile is 0.4. It means if you are going to control the orientation and location with this smaller value for the line profile, it doesn't make sense to use this surface profile. It is meaningless because everything we are going to control with this line profile and the TZ for that is smaller than the TZ for surface profile. Whenever we are going to satisfy this condition for line profile, it doesn't make sense to use this surface profile here. It is meaningless. For now, I would like to recap it. We have talked about the straightness, flatness, circularity, cylindricity, line profile, and surface profile. Just here, I would like to highlight whenever we are going to talk about the form and shape, it doesn't make sense to use modifiers the same as MMC and LMC. It is not applicable. For now, I would like to close this session regarding profile of a line. In coming session, I'm going to talk about angularity. Thank you for today. I hope you enjoyed. See you next time.